Hey everyone, welcome back to the channel. Today we are diving deep into what is arguably the most important architectural shift happening in software engineering and the artificial intelligence right. So autonomous AI agents, if you look back at 2022 and the 2023, it was an era large language model as an oracle, right? So we are all blown away by the fact that we could open up the ChatGPT or Claude, type in a prompt and get back a beautifully written essay, a quick Python function, or a summary of a long video, right? But as a developers, engineers, and the product builders, we quickly hit a wall. Text generation is not execution. Knowing how to write a piece of code isn't the same thing as checking out a repository thing or a running unit test, fixing a bug, and opening a pull request, drafting an email isn't the same logging into a Zendesk, querying a customer's order history, cross-referencing Stripe, and issuing a refund. So we are now officially moving from passive generative AI to the active agentic AI. So in this video, we are going under the hood. We are going to deconstruct the exact mental model, the technical components, the memory hierarchies, and the runtime execution loops that transform a standard large language models into an autonomous system capable of reasoning using a real world tools, maintaining state, and accomplishing complex goal on its own. Right? So grab a coffee, hit that subscribe button if you haven't already, and let's get right into it. Okay. So to kick off model one, we need to recalibrate how we think about software control flow. So as a developers, we have spent decades building deterministic systems. So you write an if-else block, you define an explicit workflow, you call an API endpoint and give an input, right? So if you guarantee to get output, it is rigid, predictable, and fully controlled by hard-coded logic, right? So when LLM first came along, the most engineers tried to treat them like stochastic API endpoints. So you send a text prompt, you get back a response, and you render it in a UI. But building a true AI agent requires a total paradigm shift. So we are moving from deterministic workflow control to intent-driven probabilistic autonomy, right? So what does that mean in plain English? So instead of writing code that explicitly tells the computer how to perform every single step, so we give a agent a high level goal, a set of tools and an environment. So and we delegate the decision making process of how to achieve that goal to a model's own iterative execution loop. So this shift is a huge, right? So if you try to build an AI agent using traditional rigid software engineering patterns, your application will break the second it hits a real world edge cases. So let's compare chatbot and AI agents side by side to make this crystal clear, right? So on the screen, look at the traditional chatbots, LLMs, or the autonomous AI agents. So let's look into the difference. So look at this comparison table on the screen. Because confusing these two concepts is the single biggest mistake I can see teams make when designing or uh, designing AI products. So on the left, we have traditional chatbots. A traditional chatbots is a inherently stateless and the passive, right? So it runs on a single request response turn. You give it a prompt. The model processes the context window, calculates the model almost statistically, likely next tokens, and splits out a string. So the second that text is generated, the model goes completely dormant, right? So it doesn't check if its answer was accurate. It can't run a terminal command to test its own code, right? So it relies 100% on a human sitting at the keyboard and act as execution layer, like we all are doing this, right? So now look at the right column, the autonomous AI agents. So an AI agent operates inside a goal-driven closed loop. So suppose you tell an agent, investigate why our database CPU utilization spiked to 95% at 2 a.m. and draft an incident report. So an agent doesn't just reply with the general troubleshooting tips. It enters an active execution cycle. So it performs a plan. It calls an API to query your monitoring logs, right? So after that, it reads the return log output. Then it is see. it sees a connection pool lookups. It pivots a hypothesis and runs a SQL query against the system tables to identify the blocking query. So if an API call fails with a permission error, it reads that error, adjusts its parameter, or asks for elevated access, right? So it's all the defining factor here is the agency. So the ability to perceive the environment, make independent decisions, invoke external tools, evaluate the outcome of those actions, and self-correct until goal is achieved, right? So these are the difference between the traditional chatbots and the autonomous AI agent. So this is the very simple and very basic difference between both. So defining the AI agent. So here is the blueprint you should keep in your head whenever you are designing or debugging an agent system. An AI agent boils down four primary primitives, right? So the first, reasoning brain. This is your core fundamental model, whether the Claude 3.5, Sonnet, GPT 4.0, or a reasoning model like DeepSeek R1. The brain's primary job isn't to hold all the facts in the world inside its head, but to serve as a general purpose reasoning engine that evaluates the incoming data, breaks complex problems down into a subtask, and decides what action to take next. Right. The second is the perception input. An agent has to perceive its surroundings. This goes far beyond text prompts. So perception includes system events, file uploads, and API responses, web search results, and the webhook payloads. Right. The third one is the action space tools. Without tools, an LLM is just a floating brain in a jar. Right. So it can talk, but it can't affect the world. The action space defines what is the agent is allowed to do, executing a Python script in a sandbox, making a REST API call, querying a vector store, or updating a database record, right? And the last is the autonomous loop. This is the runtime you usually build as a state machine or while loop that continuously takes perception inputs, passes them to a brain, extracts tool execution intents, run those tools, feeds the output back into the brain, and keeps iterating until the goal state is satisfied, right? So this is what about the agent or agentic AI or the core mental model. So if you take that high level mental model and map it to the software architecture, we get four distinct engineering layers. So perception and ingestion. This layer handles multimodal data ingestion. It passes raw code, extract text from PDFs, processes UI screenshots, or listen to real-time event streams like Kafka, converting ambient data into structured tokens the model can digest, right? So the second pillar is brain and planning. So how does an agent solve a problem with 20 steps without getting stuck in an infinite loop, right? This is the question. So this is a big question, right? So planning components use the technical or techniques like tree of thoughts of plan and the solve to construct a directed acrylic or a cyclic graph DAG of execution step, right? So it also runs self-reflection steps asking, is my current output fulfilling the user's constraints, right? So another one is the tool execution and the orchestration. So this layer provides a security or secure sandbox. So when a brain outputs a structural tool request, this orchestration layer validates the JSON schema, checks the role-based access control, executes the API request, and captures the std out or std error. Like so, output and the error or the JSON response. So this is what the tool execution. And last one is the memory stack. So context windows are infinite or finite and expensive. So the memory layer manages short-term memory, the active message thread, and the long-term memory, vector database and the key value stores. Like long-term means the vector database and the key value stores. So the agent members, so the agent remembers past interactions, user preferences, and the enterprise context across different sessions, right? So these are the core architectural pillars: perception, brain and planning, tool execution, and the memory stack, right? So the anatomy and the architecture. So this is the second model of our session. So anatomy and architecture. Now that we have or we understand the core philosophy, we are going to the dive straight into the real world code structures and software stacks. So we are going to look at the exact technical matrix, explore how tools communicate over standard protocols, break down the famous React loop, not a React. So React is basically a JavaScript library. So this is the React loop. Okay. So and trace to end execution flow. So building an agent that works 80% of the time and the quick demo is easy, right? So building an enterprise-ready agent that operates at 99.9% reliability requires a strict architectural discipline around the state persistence, right? So tool sandboxing and the safety guardrails. Let's look at the tech matrix, right? So component matrix breakdown. These so the component matrix breakdown. So component matrix breakdown is a production tech stack powering modern AI agents today, right? So let's run down the layers for reasoning engines. Choices run from the frontier instruction turn models like uh, Cloud 3.5 Sonnet and the GPT 4.0 to specialized reasoning models like DeepSeek, right? DeepSeek R1 or the OpenAI O1. So which spend extra compute time like thinking. So internally before outputting the tool calls. For planning and frameworks, we use orchestration layers like LangGraph, AutoGen, or the Llama index workflows, right? So these libraries allows us to model agent interactions as straightforward cyclic graphs rather than the simple linear chains. And for the memory, the standard setups couple fast ephemeral, right? Stores like Redis and the Postgres for managing working context with the specialized vector databases like Pinecone, Quadrant, and the ChromaDB for long-term semantic search. For tool integration, we are seeing a shift towards standardization or standardized protocols like Anthropic Model Context, MCP. Okay, so an open API specification instead of writing a custom API integration wrapper code every single tool. Like MCP provides an open standard for model to discover and invoke tools safely. And finally, the control and safety. We implement human in the loop validation checkpoints, right? So state token rate limiters and safety layers like guardrails, AI to prevent dangerous side effects, right? So these are the component matrix breakdowns, right? The next one is the React execution loop. So if you only take one software pattern away from the entire video, make sure it's this one. So a React, which stands for reasoning and acting. Before React was introduced in a landmark research paper, systems either tried to pure reasoning without interacting with external tools, or pure acting by executing hard-coded APIs, script without analyzing intermediate results. So React combines both into a four-step loop, right? So which are four steps? Thought. So the agent aspects its objective and current state, writing an internal monologue. The user wants to find an order like for example 8841. So I need to query the database first. So what is the action? So based on that or based on that thought, the model outputs a structured tool call, right? So what is the instruction for? So database query like order ID equal to like 8841, right? So what is the observation? So the execution environment runs the query and feeds the result back into the model context window like status is shipped or the whatever tracking ID or that or like and what is the synthesis and the iteration of that like the agent reads the observation and forms a next thought like have a tracking ID now I should have the FedEx API to check its delivery status like so this thought right arrow action or right arrow observation cycles loops continuously until the agent determines it has fully satisfied the user objective, right? So a react which means to do the action on the given prompt, right? So reasoning and the action. Next one is the enterprise application. Okay. So where the company is deploying this technology right now for a real business rate of interest. So three keys are landing or leading the way: autonomous software engineering, automated customer support, the deep market research. So autonomous software engineering. So looks like Devin GitHub Copilot workflows. The open source tools like Adder are doing far more than simple code auto completion. So they take a GitHub issue search of 1 lakh line code base, edit code across multiple files, spin up a local Docker container, run unit test, fix file assertions, and submit a PR for human review. Correct. Second one is automated customer operations. So moving beyond annoying rigid decision tree bots, modern agents read full account histories, verify identities, query internal ERP systems, issue refund and update CRM records end to end without needing manual agent intervention. So deep research and the data aggregation, which is the third point, right? Deep research and the data aggregation. So agent that autonomously perform web queries, pass multiple page PDFs, extract financial metrics, run statistical calculation in a Python environment, and they compile comprehensive execution summaries. So these are the three enterprise applications. So end-to-end agent execution flow. So how agent executes and what is the flow? So to bring all these pieces together, let's trace the exact chronological sequence of an agent request from start to finish. So perception and context hydration. A user request arrives and runtime hydrates the context window by injecting system instruction, environment variables, user preference, and relevant long-term memory embeddings retrieved by RAG. Okay. Second one is the goal decomposition. The planner breaks down the user request into subtasks, establishing dependencies. So task C depends on the output of task A and task B, right? Third one is the tool execution loop. So the system enters the React loop. It emits tool calls, passes execution outputs, catches API errors, and updates its working state dynamically, right? Last one is the reflection and the final synthesis. So before returning the final output, the agent enters a self-critic phase. It checks its output against the initial prompt, right? Or initial prompt constraint. So did I answer every question asked? Did I adhere to safety guidelines? Once it validated, so it returns a final answer to the user and saves the session summary to a long-term memory, right? So these are the end-to-end execution flow, right? So after that, the neural foundation and the core engine. So always remember, your agent architecture is only as good as the foundational model running as its core. So what specific model capabilities are required to build a reliable agent, right? The intelligent foundation, the strict schema adherence. So an agentic LLM must natively outcome clean JSON or XML. So if a model inserts a conversational filler like sure, here is your JSON payload, it will break your code parser. So modern models use native function calling a grammar constraint decoding to ensure valid payloads, right? So the context pillar stability. So as an agent runs through 15 tool iteration turns, right? So an agent runs through a 15 tool iteration turns a context window fill a fast. The underlying model must maintain strong retrieval accuracy, avoiding needle in the haystack degradation where it forgets instruction buried deep into a long context, right? So reasoning and text time compute. So extended reasoning capabilities allows model to evaluate multiple candidate path internally before committing a tool action, drastically reducing mistakes in the high stake workflows, right? So this is what about the intelligent foundation. So as our session is end. So to summarize, we are living through a massive technological leap in software engineering. So we have a transitioning from simple text form and responses interfaces to stateful autonomous systems that can reason, plan, execute tools, and learn from their mistakes, right? So building great AI isn't just about picking the newest model, it's about building the right cognitive software architecture around that model, right? So this is all about the agent or AI agent. So thank you so much for watching. If you found this breakdown helpful, please hit that like button, drop a comment below and what you are currently building and subscribe for more. So deep dives into technical software architectures if you or I'll see you in the next video. Right? Yeah. Thank you.